Hi, and welcome to Cracking the Cryptic. Now, I think when I've posted videos before, I've concentrated exclusively on crosswords. So today, I'm going to have a look at Sudoku, and specifically Killer Sudoku. So, as well as getting the chance to see me solve one of these puzzles live, you'll also get the chance to see me try and grapple with this technology, which I've almost never used before. So I may be struggling a bit, especially with the kind of pencil marks and using the technology. I do find that solving online is much less natural to me than solving on paper. So we'll see how that goes. And just before I load up the puzzle, which is today's Times Deadly Killer Sudoku, I'll just mention a couple of the basic principles. Normally, Sudoku is, of course, not a maths exercise. It's just a logic problem, and specifically an elimination problem, reducing the possibilities in the cells so that you know which of the numbers 1 to 9 go in each cell from the original apparent multiple possibilities. With Killer Sudoku, there is a maths element, and we'll remember the basic principle of 45, that each row, column, and 3x3 box adds up to 45, because that's the sum of the digits 1 to 9, and they must all appear once in each row, column, box, and that's often very helpful, certainly in getting a start and also in making further progress, and we'll almost certainly see that. So I'm clicking on the puzzle now. And here we go. I think, let's hope I haven't messed this up. Here comes the puzzle. Right. So, here we are. Killer Sudoku number 5738 Deadly. I'll just get that out of the way. Right. And we look at the puzzle, and the first thing to do is often to work out where there are boxes that, if we can't find any of these 45s, down in this bottom box, for instance, is quite an interesting start. You can see that the two boxes labelled 13 and 17 in the bottom right they add up to 30. By the principle of 45, these other two cells, which are in the 26 box, must add up to 15, because 30 plus 15 is 45. And because they add up to 15, these other two boxes in the 26 must add up to 11, because that'll make up 26. Those add up to 11. With those that add up to 11 and those that add up to 7, we get to 29 in this box so far. If we were to add the whole 22 that we can see here on, we get to 51. And by the principle of 45, that means this one cell that sits outside the 3x3 box, 51 minus 45 gives us 6. The other way we could have done that is by adding up all the numbers, including 22, 11, 13, 17, 26, and 7. That comes to 96, and that 96 is represented by a shape that exactly equals these two boxes plus that one cell. Two 45s are 90. Take 90 from 96, that cell must be 6. Now, because that's a 6, that limits these two other cells in the 22 box to 9 and 7. They have to add up to 16, and the only combination of that with two separate numbers is 9 and 7. This box of 7, if you've any experience at all at Killer Sudoku, you know that 7 with 3 different digits has to be made up of 1, 2, and 4. You could have that general experience in any way. Now the 11, given that 1, 2, 4, 7 and 9 have already been used up in this box, could either be 8, 3 or 5, 6. So we don't know there. However, we've clearly already got something started. Now, it's worth noting that this 8 up here includes a 1 in it as well, because 3 digits greater than 1 must make more than 8. So there must be a 1 in that, and there's a 1 in that. So the 1 in the center box can't be in the first two columns, in that cell, that cell, that cell, that cell, or that cell. It must be there, there, or there. And I would normally make some notation in the grid to show that, but I don't really feel confident with my notation on this system, so I'm not going to do that yet. Instead, I'll note this box here, a very similar principle to how we got that 6 down there. We've got 3 little numbers up here, 22, 24 and 4, and they add up to 50. And if we take 45 from 50, we'll work out the number for this cell here must be the 5. Again, we have a 7, and as we just noted, that has to be made up of 1, 2, 4. So that bulks out that box as well. It's quite interesting to note also that 23 here is a very useful number. Just as 7 only has one combination of the low numbers, 23 only has one possible combination of the high numbers, which is 9, 8 and 6. Now this cell here, we know it can't be a 6 because it's directly below it. We also know it can't be a 9 because these two cells in the 22 are 9 and 7. So that cell has to be an 8. And these two ones here have to be 6 and 9. So we've got quite a lot of this box done. 6, 9, 1, 2, 4, 5. These 3 cells have to be 3, 8 and 7. So we might as well fill those digits in, although I probably wouldn't bother normally doing that when I'm solving on paper. But the reason that that's quite helpful is if we look along this row now with 3, 7, 8 and 6 in it to this box here, the only remaining digits to go in this row are 1, 2, 4, 5 and 9. And the only way that you can make up this total of 9 with 2 of 1, 2, 4, 5 and 9 is with 4 and 5. So they must be the identities of the numbers making up 9. Now we also therefore know that 1, 2 and 9 are the other 3 items in that row. They add up to 12, and this box, this cage that they go in, adds up to 19 with one other cell apart from those ones that add up to 12, so that must be a 7. So pretty good progress here. We could limit the possibilities in this end box a bit. We've got 8 and 7, and we know that these 3 add up to 9. Now that 9 has only a number of possibilities of how that could be made up. One of them is 6, 2 and 1, which is not possible because one of these cells in the 7 must be a 1 or a 2. So 6, 2 and 1 isn't possible. So 5, 3 and 1 is another of the possibilities. If that was 5, 3 and 1, these would be 2 and 4. And then this cell would be 6 or 9, so that's really quite likely. The other possibility is 2, 3 and 4, and in fact that's not possible because one of these cells again has to be 2 or 4. So these 3 cells must be 1, 3 and 5. And in fact these cells now can't have a 1 in. And this one, it must in fact be a 1 itself. This one here, as we worked out, has to be either 6 or 9. We don't know which yet. But we're clearly making some very good progress. And this 13 box here, this is actually narrowed down a lot by what we've done in the 9 box. We found that that 9 box contains a 4 and a 5. Now there are 3 ways of making up 13. They are 4 and 9, 5 and 8, and 6 and 7. 4 and 9's ruled out because there's a 4 in there. 5 and 8's ruled out because there's a 5 in there. So these two must be 6 and 7. And that determines this box, which had to be 6 or 9. We know 6 is in there, so it can't be here. This must be 9. This one must be 6. This one must be 9. That can no longer be 9 because that's gone into the box. So 9, 7, 6, 4, 5. Those can't be 5 because there's a 5 in the 9 cage. And in fact, therefore, this must be the 5. These 3 boxes are 1, 2, 3 between them. This is 4, 5. In fact, that's a 2 because the 1 is in those 2. So that's a 2. and this one is the missing 8 from the 3x3 box. So we've got 8, 7, 6, 5, 1, 9. These three are 2, 3, and 4. We don't know, we can't narrow this one down, but we can narrow this one down. It can't be a 4, or there'd be a 7 directly above a 7. So that's 2 or 3. This one we can't really narrow down. We have worked out that these two are 1 and 9 because the 2's already gone in the cage. And again, as I say, we're making some quite nice progress. Now, up here we know that the 4 has to be 1 and 3. That means this cell can't be a 3. So we have 1, 3, 9, 6. Now 11 has 4 possibilities, and a 2-cell 11 cage normally doesn't offer you very much, but now we know that it can't be 9 and 2 because we've used the 9 for this column. We know that it can't be 8 and 3 because we're using the 3 for this column. And we know that it can't be 6 and 5 because we're using the 6 for this column. So it must be 4 and 7. And that limits this box further from 7 and 8. It now must be the 8. So these two can't have the 8 in. And in fact, this box here, which makes up an 11 either with 7 or with 3, it can't be a 4 because the 4 is in the other 11 box. So it must be an 8 to go with the 3. And this must be a 7. And now this 20 box is made up of 8 and 7 and 2 others. 8 and 7 make 15, so we've got another 5 to add. 5 can only be 4 and 1 or 2 and 3, and we're already using the 4 here in the 11, so it must be 2 and 3. And now in this box down in the southwest corner we've used 8, 2, 3, 4, 7, so this 7 must be made up of 6, 1. We can tell that which one is the 1 because of that one, and this must be made up of 5, 9, and we can tell that it's this way around because of the 5 up here. Again, that limits some of the other possibilities we noted earlier. What else can we pick up now? We have 1 and 3 there, so this number can't be the 3, it must be the 2, and that means its friend must be the 3. And as I say, we're rattling along here now. It's going very smoothly so far. We might run into some problems in a moment. Now in this column we've just got 1 box left to complete for sure. That has to be the missing 5. That doesn't necessarily help us advance very much. Let's see if we got anything here. Yes, we did. There's the only 5 in this bottom middle box. It's not possible in any of the 5 that we've written digits in, and that 5 stops those 3 blanks in column 6, so that must be a 5. To make up the cage of 11, that's a 6. These two must be 3 and 8. And that makes up 11 in this 26 box. The other 2 items must make up 15, and that's either 9, 6 or 8, 7. It can't be 8, 7 because we've already got an 8 in the cage, so it must be 9, 6. And we can tell which way round they go from this 6 and 9 here. So we've got 9, 6. That's fixed this box, the 6. So that 7 and 6 has become disambiguated. Where do we go next? The 9's here. 1, 9 in the bottom 3 in there, 1 there. This must be a 9 here as well. And below it, therefore, has fixed the 7. That 7 fixes this 11 box as 4 and 7. We know these 3 are the top 3 in this bottom right cell are using 1, 4, 7, so we can fill those in as pencil marks. And in fact, I think that's quite interesting about what the possibilities here are. Since it must be made up of either 1 4 that would give an 8 here, 1 7 that would give a 5 here, or 4 7 that would give a 2 here. I was hoping one of those would be eliminated, but actually they're all possible. 2, 5 and 8 are all possible there. Let's see where else we could go now. Here we know that to make up this 7 box, this has to be either 5, 4 or 3. This has to be 8 or 9. And now the possibilities that we've opened up here don't include 6 in this column. In this 5th column, none of the possibles that we've got in the bottom 7 cells can be a 6. This can't be a 6 because that would leave the other 2 digits in 8 to be 1 and 1, which couldn't go together, so that must be the 6 in this set in this column. Still not quite, so we're probably only one breakthrough away from really having this fully cracked at this stage, so we just need to try and figure out what that might be. This 25 cage has got 17 in down below the line, so that's 8 above it. That 8 and that 21 would make 29, that would leave 16 in the other 3 cells, that's not all that helpful. Down here, 6, 8 and 3, rule out the 3 from this box. So it's either 4 or 2, that's not all that progressing for us. Yes, here. Now we did work out earlier that this 8 cage has a 1 in it, and this 7 cage has a 1 in it. Between those two 1s, they must account for all the 1s in columns 4 and 5. So this cell here cannot be a 1. So that has to be a 9 out of the possibilities. That fixes that 1 next to it. And now coming up here, we've got 3, 8, 6, 1, 5, and 2 or 4. I'm just thinking that this 26 box, that has to all be quite big numbers. If it was 9, 8, 6, 3, that would be possible, but since 3 and 8 have both been used there, that can't be it. One of them would have to go in there. It could be 9, 7, 6, 4, or could it be as little as 7, 6, 5, 4? No, there can't be a 5 in it, interestingly, because there's a 5 here that blocks those 2 cells, and there's a 5 there that blocks that one. So it's not 9, 8, 6, 3, and it doesn't have a 5 in it. So I'm thinking that 9, 7, 6, 4 looks the most likely combination possible. I have a feeling that that is in fact the only possible one left if there's no 5 and there's no 3 in it. And there is a 6. Yeah, I'm confident enough about that to go ahead. So that has to be the 4 because there's a 9 and 7 below it. These two have to be the 9 and 7. And because the 9 has been decided in this box, this one in the 11 has to be its 8. That fixes a 3 here. That rules out 3 from this one, and that rules out 4 from this one. Now in this top box we've got 9, 6, 3, that has to be 2 or 4. That hasn't quite narrowed down how this 8 is made up. 8 can only be made up 2 ways, and but we haven't managed to decide quite which one it is yet. This one here is either 1, 2 or 4. But this 18 here, now we've worked out by elimination that both of its left-hand cells are 2 and 4, so that makes 6. So we've got another 12 to add. That can't be 8, 4. So it could be either 3, 9 or 5, 7. Certainly not absolutely sure which at the moment. still, I think we haven't quite made that final breakthrough that we need to finish this one off. Here in this cell we've now got the 4 and 7 fixed, so we know this is the 1. That fixes this 3, the one next to it. Now we know there must be a 1 in that column, but we also know that these two are 5 and 8. This one can't be the 8 because of the 8 in the same row, so that's 5. And that's 8. And now this 18 box already has 11 in it from the 4, 2 and 5, so it needs another 7. This 25 here was made up of another 8 after the 17 we've already got. That 8 can't be 5, 3 because of that 5, and it can't be 7, 1, so it must be 2, 6. So we can fill those in. Not sure which order yet. 2, 6, 8, no. 2, 6, 8, 9. This must be the 1 because the other 2 blanks are prevented by the 1 down below, and these 2 must be 3, 9 between them. This must be 4, 7. This must be 4, 7. And in fact, this one here can't be 7 because of the 7 above it. So that's a 4, that's a 5, that's a 4, that's a 7. These 2 down here must be 5, 3. Then we've got, to make up the 17 here, that's 10, 15, we need a 2. This is 8. That fixes this as 3, 8, 2. And we're really progressing now, and I think we've probably made the last big breakthrough we needed here. So hopefully we can just finish off from here fairly straightforwardly. The 1 in this 8 can't be in the top, so it must be in the second row, and therefore the 1 in the third row must be here. And that helps fix that 3. That 3 fixes this 9. That fixes that 3. That 9 fixes this 7, and it becomes a bit of a domino effect with everything now falling as deduced. That 2, 8, 7. To make up 22 we need another 2. That gives us 4, 2. We've got 6, 4, that's 9. And these are fixed by the 2 that's appeared in row 2. That fixes these 2. Everything's getting resolved now. This is 1 and 4, and it must be that order. This is 1 and 5. These numbers are all disappearing as the puzzle recognises that it's complete, and there we are. Congratulations. Done in 21 minutes with a lot of explanation there, which is fine. I think there's normally a recommended time on these puzzles, and once they're deadly it's normally over 45 minutes, so that's not bad time, and that's even with all the explanations being provided and me mastering the new software. So I think you can see that once you know what to look for, once you're used to applying the rule of 45 and how the boxes fit together, it all becomes a lot more straightforward than it may look initially. Not saying it's easy, and it's still taken some time, but the puzzles are manageable as they sometimes don't appear at first. So thank you very much for watching. Hope you enjoyed that, and hope to see you again on Cracking the Cryptic in the future.